Ever wondered how secure your Kubernetes clusters are? In the grand scheme of things, cybersecurity is paramount. This is especially true when dealing with Kubernetes, an open-source system that automates deployment, scaling, and management of containerized applications. Understanding the security primitives of Kubernetes is not just an option, it's a necessity. It's the foundation that dictates how well protected your applications are. So let's dive in, shall we? In the next few minutes, unravel the mysteries of Kubernetes security primitives. Dive into the world of Kubernetes security primitives. Kubernetes, a powerful system for managing containerized applications, is packed with security primitives. These are the fundamental aspects of Kubernetes security that help safeguard your clusters. With these primitives, Kubernetes ensures a secure environment for your applications. Let's start with Role-Based Access Control, or RBAC for short. RBAC is a method of regulating access to computer or network resources based on the roles of individual users within your organization. In Kubernetes, RBAC allows you to define who can do what within your clusters. You can set permissions and roles for every user, allowing you to control who has access to your data and how they can interact with it. This level of control is crucial in maintaining the integrity and confidentiality of your applications. Next, we've got network policies. These are specifications of how groups of pods are allowed to communicate with each other and other network endpoints. They provide a robust firewalling mechanism between pods running in a Kubernetes cluster. In simple terms, network policies are like traffic rules for your pods. They define which pods can talk to each other and how, ensuring that unwanted or unauthorized traffic is kept at bay. Finally, let's talk about pod security policies. These are cluster-level resources that control the security-sensitive aspects of the pod specification. They dictate what security conditions a pod must comply with in order to run in your cluster. For instance, they can enforce that pods run as a non-root user, or that they can't use privileged containers. Pod security policies act as a gatekeeper, ensuring that all pods adhere to the security standards you've set. Understanding these Kubernetes security primitives is crucial in managing and securing your clusters. They provide a solid foundation for Kubernetes security, allowing you to control access, regulate traffic, and ensure that your pods comply with your security standards. With these primitives in place, secure your Kubernetes clusters like a pro. Ready to implement these security primitives in your Kubernetes clusters? Let's get started. First off, we have Role-Based Access Control, or RBAC. This is a method of regulating access to computer or network resources based on the roles of individual users within your organization. It's all about limiting access to only what is necessary for each user, a principle known as the least privilege. Next, we have network policies. These are specifications of how groups of pods are allowed to communicate with each other and other network endpoints. By default, pods are non-isolated. They accept traffic from anywhere. But with network policies, you can change this and control the traffic flow at the IP address or port level. Then, we have pod security policies, or PSPs. They are cluster-level resources that control security-sensitive aspects of the pod specification, like the use of privileged containers, access to host file systems, and the use of host networking and ports. Now, you might face some challenges while implementing these primitives. You could find the process complex or encounter issues with misconfigurations, but don't worry. There are tools like KubeBench and KubeHunter that can help you check your configurations and identify potential security issues. Remember, the key is to understand your cluster's unique needs and tailor your security measures accordingly. Implementing these security primitives is the first step towards securing your Kubernetes clusters. Now that you've got the basics, let's summarize what you've learned. Kubernetes security primitives are fundamental elements that play a crucial role in securing your Kubernetes clusters. They provide you a framework to manage and control access, secure sensitive data, and protect your system from vulnerabilities. The authentication primitives ensure that the identity of the users or system components is verified. Authorization primitives, on the other hand, determine what authenticated users can do. Admission control primitives control what resources can be created or modified, while pod security policies dictate what a pod can and cannot do. Network policies allow you to control traffic flow, and secrets help you manage sensitive data. The role-based access control, or RBAC, provides a means for administrators to define roles and assign them to users. And let's not forget security contexts and service accounts. They define privilege and identity at the pod and container level. Remember, securing your Kubernetes clusters starts with understanding and implementing these security primitives.